just in case anybody needs it. So we're starting to talk about dimensional analysis. It is also called the factor label method. And it is also called unit conversion, which is probably the best name for it, being that that is what it is. So this dimensional analysis involves things that are equal to one another. For example, 1 kilometer equals 1,000 meters. And we can use that equality to set up what are called conversion factors. Conversion factor is a fraction with a denominator and a numerator. And you can see for this equality, can you guys see the arrow moving around on the screen? Could you just give me a thumbs up if you can see the arrow as I'm pointing? Okay. So for this equality, there are 2 possible conversion factors, one in which meters is on the top and one in which meters is on the bottom. And it works like this. If you take something and divide it by itself, it's 1. So 5 divided by 5 is 1. If you take 12 divided by 12, it's 1. If you take 12 divided by 1 dozen, that's also 1. Because these 2 things are equal to each other. Or if you take 1 dozen divided by 12, that's equivalent to 1. So a conversion factor is a fraction in which the thing in the denominator and the thing in the numerator are equivalent to each other. So one of the things that we have to do, since there are 2 possibilities for every equivalency, we have to choose the right one. And our goal is unit conversion. And our goal is unit cancellation. So a conversion factor must cancel the original unit and leave behind a new unit. So this is how a problem would be set up, converting meters to kilometers. What we can see is that the unit in the denominator, in the numerator, the first unit that we have is meters. And in our first conversion factor, we put meters in the bottom because our goal is unit cancellation. Just like 2x over x is equivalent to 2, since we have the unit, this unit on the top, and our starting would be like a numerator, and this in the denominator, that unit cancels. So the unit in the denominator always must be the same as the unit that you either start with, or if it's a multi-step unit conversion problem, the most recent numerator. So let me show you, just take you through the process. These examples include some 1-step unit conversions, and then I'll show you a multi-step in a bit. And so the goal is to convert 215 centimeters to meters. What I always do is I write down what the number that I'm given and the unit. And I give myself some space. And I write down what it is I'm trying to find. Now I need a relationship between centimeters Do we have an Owen in this class? No, I have Owen in the third hour. I think Owen's confused. He'll have to wait. So I wrote down what I started with and what I'm trying to find, and I need a relationship between this. Now I know that the prefix centi means 1/100th. So that means it's 100 times smaller than a meter. So my equivalent would be 1 meter is equivalent to 100 centimeters. And I have two possible conversion factors with this. I could put 1 meter over 100 centimeters, or I could put 100 centimeters over 1 meter, and I have to choose the right one. In this case, I know for a fact I have to have centimeters on the bottom because my goal is unit conversions. If I have centimeters or unit cancellation, if I have centimeters on the bottom in my first unit conversion, I will get my unit cancellation. So that leaves me with 100 centimeters on the bottom is 1 meter on the top. Now this is really just multiplying fractions. So anything on the top gets multiplied and anything on the bottom gets divided. So 215 divided by 100 is, I should be able to do that in my head, but I could not. I did not. So now we have to talk about dreaded significant figures. With unit conversion problems, we will always look at how many significant figures are in the first number, and that's how many we have to express our answer to. We do not look at the numbers in, even though we're multiplying and dividing, these are exact quantities. So these conversion factors are not considered for determining sig figs. I have a lot more control using this to write than I did within that PowerPoint. It's kind of nice. All right, so this is my final answer. It has 3 sig figs, just like the other one did. Now the relationship that I came up with, 1 meter is 100 centimeters. I used that by logic, but I will show you that in this conversions and equations sheet that I gave you, that relationship is also shown right there. Which leads us to the next one. The next one, we're converting meters to kilometers. So I know that kilo means 1,000 times bigger, but I also have this relationship here. 1 kilometer equals 1,000 meters. So I'll start this problem the same way. I start by writing what's given. I know that I need to have meters in the denominator of my first conversion factor. And I know that I'm trying to find kilometers. Kilo means 1,000 times larger. So 1 kilometer is 1,000 meters. my meters unit cancel, and my answer will be 0.125 kilometers. So I start by punching the number into the calculator, 125. I multiply by anything that's on the top and divide by 100. So 125 times 1 divided by 1,000. I realized that I said 100 there and that was a mistake. And I get 0.125. And that is my final answer, since my answer needs to be expressed in 3 significant figures. So let's look at this one together. How many micrometers are in 0.3 meters? So writing down what's given, 0.03. My words keep saying the wrong things. My mouth keeps saying the wrong words today. My conversions chart does not have a relationship between meters and micrometers, but I'm going to use my logic to get there. I learned that centi meant 1/100th, and milli means 1/1000th, and micro meant 1/1,000,000th, which means 1,000,000 times smaller. The prefix for centi is C, for milli is M. Micro has that weird Greek symbol U. Mu is what it's called. So I know that a micrometer is 1,000,000 times smaller. Therefore, 1 meter is equivalent to 1,000,000 micrometers. I have to have meters on the bottom because I'm going for unit cancellation. And 1 meter is 1,000,000 micrometers. So since that 1,000,000 is on the top, I take 0.03 times 1,000,000, and I get 30,000. Notice that here I have 1 sig fig, and in my answer I also have 1 sig fig, because these are leading zeros, which are not significant, and these are trailing zeros, which are not significant. All right, and there's the answer, 30,000. Now, the next problem involves multiple steps, and we have to convert 1 day to seconds. I know that this one's going to involve a lot of space. Usually I just automatically give myself a lot of space. Now, what we need to do is think about what we know. I know that 1 day is 24 hours. I know that 1 hour is 60 minutes. I know that 1 minute is 60 seconds. So while I don't know off the top of my head how many seconds there are in 1 day, I know all of these other things. One thing that I want to point out is my 1 day has one significant figure, which we're going to need to keep in mind when we express our final answer. So setting up my first conversion factor, I know that I need to have days in the bottom because I need unit cancellation. And what I know about a day is that it's 24 hours. If I was solving for hours, I could stop the problem right now, but I'm not. So I need another step. And I have to have hours in the denominator of the next conversion factor so that I get unit cancellation. I know that 1 hour is 60 minutes. And we are still not at our destination yet, which is seconds. So I need another conversion factor in which I put minutes in the denominator so that I get unit cancellation. And 1 minute is 60 seconds. Now, since all of these values are on the top, I will multiply straight across. 1 times 24 times 60 times 60. And my calculator says 86,400 seconds. And it seems like it would make the most sense just to express our answer this way. But we can't. Since our first measurement rounded was one significant figure, we need to round this to one significant figure. So I'll write it again, 86,400 seconds. If I'm rounding to one significant figure, I'm going to underline the first one that's significant. I'm going to look to the next. This 6 will cause the 8 to turn to a 9, and I will fill the rest with zeros. So my final answer, based on the rules of significant figures, would be expressed as 90,000 seconds. Some people have a serious problem with this. It seems like it would be inaccurate. But since this is a multiplication and division problem, we have to follow the rules, and the final answer must be expressed in the same number of significant figures as the measurement with the fewest sig figs. And I will remind you that we do not take these into consideration. We're not concerned with conversion factors when determining how many sig figs to round our answer to. So since this is one sig fig, my final answer is rounded to one sig fig. So this is where I'm going to end today. I know that I technically have you for another 7 minutes, but I know these days also get long, so I'd like to give you a little break. Tomorrow in class, we'll go through the rest of the examples in this slide presentation, and then we're going to do some practice in class. So I will, I'm just going to stop the recording here, and then I'm going to stay on if anyone has questions, but if not, you're welcome to leave, and we will practice tomorrow.